Calculus kids, this is Dr. Callahan with week 6 Thursday. How are you guys doing? Go ahead and pause the video to answer the following 3 questions on your warm-up log. All right, let's go ahead and start your assignment for today for calculus. All right, so today is for week 6 Thursday. Our topic of discussion today is specifically going to be on base other than e. So integrals and derivatives of bases other than e when it comes to natural logs. So let me just go ahead and prepare AP Calc, AB semester 2. All right, so the 2 things that you will need is make sure you guys have your links for calculus. Check in with me by 9:41 a.m. and make sure you submit everything by 3 p.m. And I'm just going to sign up. All right, you guys, so let's go ahead and get started. So take a look at the breakdown for today. Well, right here, your quiz on Wednesday was for you to pick any 10 questions out of 17 here. So make sure you guys go ahead and do that. This is a breakdown we're going to be talking about. We're going to do a foldable in class. Although if you're doing this at home, you could just write it on a separate piece of paper. That's completely fine. Your guided notes for today looks as follows. So week 6 Thursday, this is the first page. Here are some of the notes and also the steps to the exponential bases other than e. Page 2. Page 3. These are the theorems that you're going to be specifically using for the derivatives of bases other than e. The textbook. And that's basically it. So with that said, let's go ahead and get started with some of the examples we're going to go over in class today. All right, so here we go. Today we're going to be using 5 theorems simultaneously today. Make sure to know which theorem to use on which problem. This is also going to be in your guided notes for week 6. So take a look at the derivatives for bases other than e, and then we'll go ahead and get started. All right, let's go ahead and review a few things from Algebra 2. There are 2 different types of questions. First is the solve for x, and the second one is going to be on derivatives. Here's the first flap, or the first foldable. So looking at this right here, go ahead and pause the video, and that's a review from Algebra 2. Which one of these are going to match the answer here in the red? So pause the video and do that. All right, so if you were to go ahead and rewrite this, you know it's 2 to the negative 4th equals x. Bring the negative 4 down to the denominator. And then, of course, 2 to the 4th power is 2 times 2 times 2 times 2, which is 1 over 16. Same thing over here. You have your base of 3. So another way of writing 1 over 81 is going to be 1 over 3 to the 4th power. If I were to go ahead and rewrite this as 1 over 3 to the 4th power, I can also bring that up to 3 to the negative 4th power, and then as such, x is equal to negative 4, and that is your answer. Looking at this one here, 7 to the x is equal to 1. So as you think about this, what can x equal in order to get the same base? It is going to be 0. because 7 to the 0 power is 1. Any number to the 0 power is just 1, so x is equal to 0. Whenever you deal with a log, it's always going to be the a to the x power equals 1 over a. Now, you could go ahead and rewrite this because in order to have the same base, you have to have a to the negative 1 power. So then as such, x is equal to negative 1. All right, so let's talk about the second one. These are examples for derivatives for bases other than e. So looking at a, b, and c, here are the theorems that you'll be utilizing. And it's pretty straightforward initially because we look at this right here. Which theorem are you going to be using for y equals a to the x? Well, probably first one. So you just simply replace a with a 2, x, well, just an x. So ln 2 in parentheses 2 to the x. So that's pretty straightforward. Over here for b, you're probably going to be using a to the u. So it's just going to be a is equal to 2, u is going to be 3x. So ln 2, 2 to the 3x times du is going to be u prime. So that's going to be just 3, so times 3. So pretty simple overall. For c, this one is going to be a little bit more complicated because what you're going to do with this one is that you are going to go ahead and let u be cosine x. Then what ends up happening is you're going to have the derivative of u, which is going to be negative sine x dx. Then you're going to have du divided by x equals a negative sine x. If you go ahead and take a look at your derivative, which is log a u is equal to 1 over ln a times u times du over dx. So what this means is that with a log, it has a natural base of 10. So your a is 10, u is cosine x. So then once I have the components here to put it into the equation, then naturally then I know a is going to be replaced with 10. U is going to be replaced with cosine x, and du over dx is going to be replaced with negative sine x. And that's what you have right there. Now, if you have a sine over cosine, you know another way of writing that is just tangent. So this is another way for you to rewrite that. All right, so let's go ahead and take a look at number 3. So looking at number 3, keep in mind that this is going to be equal to 1 over ln 2 times 2 to the x plus c. Because the formula given to you here is integral of a to the u dx equals 1 over ln a times a to the u plus c. So you should probably go ahead and try to match the formula. So you can see that a is going to be x u, I'm sorry, a is going to be 2, u is going to be x, and then of course dx is just dx. So then ln a is going to be a 2, 2, u is going to be x, and then plus c. So third one is pretty straightforward. Fourth one is actually pretty straightforward as well. It actually doesn't have anything that is too difficult. As I look at this right here for the integral of 2 to the 3 to the x dx, you know that the integral of a to the u dx is equal to 1 over ln a times a to the u plus c. So naturally, you're probably going to say, let u be 3x. You know that your a is going to be 2. So then du is going to be 3 dx. And you always want to have it so you have a du over dx, which is just going to be 3. So then naturally, if I go ahead and extend this, I will have 1 over ln a. So 1 over ln, replace a with a 2, replace a u with the 3x, and that is your answer. All right, let's take a look at this one. Pause the video, see if you're able to do this one on your own, and then here is your answer. All right, let's take a look at this. You know that the integral of a to u dx is equal to 1 over ln a times a to the u plus c. So matching this right here, I can see that I'm going to go ahead and let u be 3 minus x squared because that's how it's being matched, okay? And then I also know that a is probably going to be 7. So then I know that my du is going to be 2, 3 minus x times negative 1 dx. So then I know that du over dx is equal to a negative 2 times 3 minus x. Now that I have this in place, it is equal to 1 over ln a. So 1 over ln a is going to be, and actually before I proceed any further with this, I know that if I go ahead and replace, let's see, 3 minus x times 7 to the u power, change your dx to a du over negative 2 times 3 minus x. Notice that you're going to be able to cancel this part with this part, and you're left with a negative 2 integral 7 to the u du, okay? And so if I were to go ahead and match it to the formula right here, then I know that I will have 1 over ln a, your a is a 7, times a, which is 7, to the u, and your u again is 3 minus x squared plus c. You do have a negative 2 in front over there, so don't forget the negative 2 in the front. I'm sorry, your negative 2 is in the bottom, so it's actually a 1 over. Sorry, let's move that onto the bottom. Negative 1 over 2. So then if I rewrite this here, it'll just be a negative 7 to the 3 minus x squared over 2 ln 7 plus c. For number 6, let's take a look at the integral of this. And once again, you're using this formula right here. So you want to somehow modify your question so it looks similar to that formula. This is your answer, by the way, on the very bottom. So we're going to start off with identifying what is going to be your u. So as I am looking at this right here, I can see that my a most likely would be the 5. My u is going to be a negative x squared. Then my du is a negative 2x dx, and my dx is equal to a du over negative 2x. So let's go ahead and rewrite this. I have x times 5, which is going to just be 5, negative x squared to the u power, times dx, which is a du over negative 2x. I would be able to go ahead and cancel the x here and the x here, and I'm left with a negative 1/2 integral phi to the u du. So if I look at this, you know that if I match it to my formula, it is going to give me ln a again is going to be a 5, and your u is going to be negative x squared. So negative 1/2 1 over ln 5 to the negative x squared plus c. Now, of course, you want to clean this up a little bit. So you'll put the 5 to the negative x squared in the numerator over 2, and make sure you have a negative there, ln 5 plus c. And that is my answer. All right, take a look at example 7. This is our second to last one. This is the answer right here. So pause the video and see if you're able to get from here to here. Okay, so let's go ahead and take a look at this. This one's a little bit tricky because you have a 3 to the 2x over 1 plus 3 to the 2x. I'm like, I want to have u to be 2x, but there is just no way that I can cancel the 1 plus 3 to the 2x. So let's go and see what happens when I let u be 1 plus 3 to the 2x. Okay, so if I let this have this, then du is going to be equal to derivative of 1 is just going to be 0. But then the derivative of 3 to the 2x, on a disclaimer on the side, just remember derivative of a to the u is equal to ln a times a to the u times u prime. Okay, there we go. So then a to the u times u prime. So I'm going to go back. Sorry, I gotta get rid of that stupid drum sound. Okay, so then looking at this right here, you know that your a is going to be 3, your u is going to be 2x, and your u prime is going to be 2. So replacing this, I have ln a, which is 3, times 3 to the u times u prime. So I'm going to put a 2 right there, dx. All right, so let's go ahead and rewrite this thing. Integral 3 to the 2x over u, because I'm replacing that. Replace your dx times, your dx is just going to be du divided by 2 ln 3 times 3 to the 2x. And looking at this part right here, I can see that I am going to cancel this part. And then I am left with, if you think about it, integral of 1 over u is ln u plus c, right? So I have a 1 over u right here perfectly, but I have all these other things that I can maybe just move it over to the left side. So I'm going to put a 1 over 2 ln 3 integral 1 over u du. And then you just move forward. So then I will have 1 over 2 ln 3, because if you think about it, ln 3 is just a constant. Integral 1 over u is ln u, and what is u again? U is this piece right here, so 1 plus 3 to the 2x plus c. And this right here, boys and girls, is your answer. All right, last example, which is number 8. Integral of 2 to the sine x times cosine x dx. remember your formula that you want to use. Sorry, there we go. And so looking at this right here, I'm going to go ahead and say let u be my sine x. Du is going to be a cosine x dx. My dx is du over cosine x. So rewriting this, 2 to the u times cosine x, replace the dx with du over cosine x. And guess what? You are able to cancel this. So the integral of 2 to the u du. Now you know that you have a formula here, which I'm going to go ahead and carry it over. Okay, which is right here, that the integral of a to the u dx is equal to, now remember you're going to have a, which is going to be equal to 2, u, which is going to be equal to, well, that's just going to be u, okay? So then you have ln a, which is a 2, a, which is a 2, u plus c. So then my answer here is going to be, let's see, 1 over ln a, which is 2, times a to the u, which is 2 to the u. And what is your u again? Your u is sine x plus c. So if I go ahead and rewrite this, which I don't really have to, it'll look something like this. And that is your answer, you guys. All right, so what I would recommend you guys doing right now for the rest of the class period is I will highly recommend that you go ahead and read the breakdown of how some of these things works with integrals of these exponential bases other than e's, and then just practice with some of these questions. Read the parts in the textbook. Take a look at some of the examples here. Example 1, example 2, 3, 4, and 5. All right, you guys, as always, stay safe and healthy, and I'll see you guys next time. Take care.